All right, so starting Unit 6, we are first going to talk about just the basics of a quadrilateral. As we move through Unit 6, we're going to get into some specific types of quadrilaterals, but we're just going to start out with a basic definition. So, a quadrilateral is a closed geometric figure with four sides and four vertices. Diagonals join opposite or non-consecutive sides. Okay, so an example of a quadrilateral that would be a square. You could also have a diamond, some sort, anything. They could all be different shapes, right? As long as it's closed, meaning it comes together. Something that would not be is four sides that might look like this, right? Um, when we look at diagonals here, we're saying they join opposite, which is non-consecutive vertices. So if I'm looking at this shape right here, it would be joining from here to here. Okay, so diagonals join opposite vertices, and we'll talk about that a little bit more. So some properties to note, we have consecutive sides. Consecutive is just another word for next to, right? So PS and SR are consecutive sides, okay? And then non-consecutive would be opposite. Those are the words that you'll hear myself and Mr. Cross use. So PQ and SR are opposite or non-consecutive. They're not touching. So same for vertices. We could have opposite, so non-consecutive vertices. Let me do this in the same color. So Q and S, right, are opposite. Anytime it says non-consecutive, right, opposite. And then lastly, SQ is a diagonal. So again, that connects non-consecutive sides. Okay, important one here, the sum of the measures of the angles of a quadrilateral is 360 degrees. So with triangles, the magic number was 180. If you think about that, if I split this shape, right, I really have two triangles. So 180 plus 180 gives us our magic number of 360. Okay, so all the angles of a quadrilateral make 360 degrees. All right, so let's look at an example here. First, we're just going to name the vertices. Those are just the corners, right? So I have D, G, F, and E over here. So we would just list them with commas in between to show that they're just points. Okay, so consecutive sides, let's look at that. We would have, right, GF and FE. I could also have FE and ED. I could have ED and GD, and then I could have DG and GF. So one thing that you'll notice, right, with these consecutive sides, they're going to share a letter, right? Because that's the vertice that they share, okay? Right? GF and FE, they have vertex F in common. So FE and ED, they share vertex E. ED and GD, they share point D. And then DG and GF, they share point G, because that's how we know that they're consecutive. All right, if I'm looking at vertices, consecutive, right, would be G and F. They're next to each other. We could have F and E. They're next to each other. We could have E and D. They're next to each other. And then we could have D and G. All right, so again, consecutive, you just want to think next to. Okay, if we're looking at non-consecutive, remember, non-consecutive really just means opposite. So if I'm looking at opposite sides, I don't have as many pairs here, right? If I'm looking at opposite sides, let me clear this out for a second. Okay, I could have GF and DE, right? That's an opposite side. They're not touching at all. And again, if you notice, they don't have any points in common. That's how we know that they're not touching. Okay, I could also have GD and FE. That's it for opposite sides. We only have two pairs of opposite sides. Okay, same with vertices. Opposite, so I could have E and G. They're not next to each other. And the only other pair would be F and D. Again, they're not touching at all. Those are opposite or non-consecutive. Okay, now this is going to have to do with that 360, right? So we want to find the measure of angle M. Let's just say I draw a shape. We know it's a quadrilateral. It's kind of a quadrilateral. It's not great. Okay, so I have K, L, M, and N. Doesn't really matter what your picture looks like, but I know K is 2x, I know L is 2x, I know M is 2x minus 20, and I know N is 3x plus 20, right? Well, we said the magic number for quadrilaterals is 360. So all I have to do is take these variables, these expressions, and set them equal to 360. So I'm going to take angle K plus angle L plus angle M plus angle N and set it equal to 360 degrees. So 2x plus 2x plus 2x minus 20 plus 3x plus 20 equals 360. Okay, now let's look at like terms. So I have 2, 4, 6, 7, 8, 9x. And then I have a negative 20 and a positive 20. So if I add those together, they get 0. So they cancel out. And then that just equals 360. Divide by 9. And I should get x equals 40. Okay, so that's part 1. I'm not done because it wants me to find the measure of M. So I have to plug that in over here. So 2 times 40 minus 20. 2 times 40 is 80. So that would be 60 degrees. So the measure of angle M is 60 degrees. Okay, so step 1, use that magic number of 360 to find x, and then use x to find the missing angle. Okay, so we will look at some more examples of this. I know everything on here was kind of quick, but we will do some more in class together. So stay tuned.